Welcome to the session. So let's continue the linked list part only. Now our major agenda is to modify our linked list. How? So in this session, I want to do the insertion of a linked list, but at the front. Means at the beginning, I want to insert any node inside the linked list. So we will try to see how we can do so, and then followed by the implementation of the same. Now, linked list data structure, I found it very easy. Why? Because it's just a change of pointers, and with the help of changing the pointers, I can able to do anything whatever I want to do in a node. How I am saying this fact, let's try to understand. Here, if suppose, let me first of all create a linked list. Fine. So for example, here I have a node like this, like this, like this, and like this. And here we will be having the data followed by the pointers that we have. Fine. So here we will be having suppose 20, 40, 69, 75 and 85. Every node has its own address, correct? For example, it will start from 100, then it will be having 200, 400, 700 and 900. And the starting address of this node is 100, which I can say is the head node. We already had a great discussion about that, right, in our previous session. Now, as a node, we have two things. One is something that we called as a data, and the second thing is something which we called as a pointer. Suppose I am assigning it as a next pointer. So what I am doing here is that I am trying to basically access the first node with the help of this head pointer, correct? Now what I can do is that I can pass in the next pointer, the address of the next particular node. So here 400 will be assigned, here 700 will be assigned, here 900 will be assigned, and here it is something which we have is none. Can I say? Simply, if you will observe here, it is 400. Now this will be assigned here, this will be assigned here, and something like that. So this kind of architecture we will be able to form whenever we want to do the insertion of a node, correct? So now I want to do the insertion at the beginning. That is my main point. So for example, if in future a new node is coming into picture which has its own data and has its own next pointer. Now suppose I want to insert the new node. So this is my new node that I have, correct? The data is 10, and initially obviously the next pointer will be initialized as none only. Now the point is that how will I assign this node as the initial part of the linked list? How will I assign this node as a beginning of the linked list? That's the important thing. That's the important factor which I need to understand here. Okay, for that what we can do is that, which is coming in my head and I think for everyone as well. If somehow inside the function I will be able to, so here it is the data, right? This is the new data that I am having. And I can say that this is the next pointer that we have, which is basically responsible to store the next memory address of the node, correct? So my purpose is that my node should look like 10, followed by 20, followed by 40, followed by 69, followed by 75, followed by 85. Can I say? This is the thing which is required. This is the thing which I want, because I want to store my node at the beginning of the linked list. Correct, everyone? Now, what I can do here is that I can simply do one thing, which I can easily see here. What if I will able to store whatever be the new node next value? Can I write that value, assign that value as whatever be the value of head that I have? Self.head means current linked list which we are talking about. The head value of that, what I can do that, I will just copy that value or I will assign that value to the new node. So now what will happen is that this particular new node automatically will be able to redirect to this particular first node that I have. Can I say? This thing will happen clearly. But still, one thing is still left. That is because my head pointer, which is basically responsible to point to the first node, head pointer which is basically responsible to point to the first node, I need to change that as well. Can I say? So in order to do that particular thing, what I can do here is that I can simply assign that value now, because now I have made use of that particular thing, to the new node address. So simply you can write it like this. So what will happen is that now your head pointer will be having the value of the memory address of the new node. So for example, if it will be 500, so it will be assigning it as 500. So now what will happen is that this linkage will be breakdown and this head pointer will start pointing to this node. And that's what we want. We want our head pointer to point to the first node, and we want this 10 as the first node as an output, correct? So this is what will happen. So here if you will see, just by these two steps, the very first step where I am picking up the previous head value and assigning it as the new node next pointer, so that my new node will start pointing to the first node in the linked list that I have. And the second thing is that because head pointer is something which is responsible to point to the first node, what I will do is that I will try to assign that head value to the new node address value. Now with the help of these 2 pointers change, what I can do is that I will be able to get the time complexity as big O of 1, which is something, can I say, as a constant time complexity, right? We will be able to get the constant time complexity, correct? So this is something that we will be able to get when we are doing an insertion of a node at the front. I hope that these two steps are pretty much clear to everyone. Now what we can do is that whatsoever we have understood so far, we'll try to do the implementation of the same, right? So that's why if you remember in the very first session, I told you that whenever we are doing an insertion and deletion as a quiet operation, instead of going for array-based data structure, we usually prefer to go for a linked list. Because see how easy the operation is. Just with a single two steps by changing the pointer thing, we will be able to get the outcome, right? So now let's get started with the implementation part without any delay, so that whatsoever we have understood will be pretty much inside our head. So what we can do here is that we need to create a separate class for a node, because node is something which contains two things. So what I can do here is that I can simply do the initialization in Python, where I am having the self, which is the instance of a current class that we have, and after that we will be having the data, right? Now what we can do here is that we can simply define that self.data is something which is equals to the data that we have, and the value of the self.next pointer is something which is equals to none initially, correct? Now what we can do after that, we can simply define a separate class named as linked list. We can simply define a separate class named as linked list. Inside that we can initialize the value with the head pointer, correct? Where the initial value of self.head is something which is equals to none, correct? Now we can define the functions. For example, the first function which I want to define is the insertion at the beginning or at the front of the linked list. Front of the linked list. Fine. So here we can define the function, maybe insert at beginning, right? And here what I can do is that I can simply take the new data, correct? And what I can do is that I can define a node corresponding to that new data. So I can say new node is something where I can call this node class, right? And inside that I can mention that new data. So now my new node will automatically be created, and I can define that the value of new node dot next, because I want to do the insertion, right? So here if you will see, this is something which is a step of creation of the new node. Creation of the new node. After that, what we want is that now there is a step where we actually want to do the insertion at the beginning, right? So here what we can do is that just now we have understood two-step game is there. New node, next I can assign the value of self.head, whatever be the value that I will be able to get, can I say, right? And finally, I can change the value of self.head with the new node address that I have. It's done. It's so simple, right? Now suppose I want to print the linked list completely. So how basically we can do here the printing of a linked list? What we can say is that def print list can be the function. Inside that we can pass the current linked list that we were working on. Here what we can do is that we can define one temp variable whose value will be initialized with the obviously the head pointer, because the very first node is this is the pointer which is pointing to the first node. So that is the temp value which I am assigning here. And then what I can do is that I can make one simple while loop, and I will say while the value of the temp will not equal to null, do one thing, just try to print the data. So what we can do here is that we can just simply convert the data into the string. So here we are doing a typecasting temp.data, and after that we can just make a separate space just to make the things more spacious. And after that we can do end is equals to spaces there. Now in order to increment to the next node, what I will do, I will say temp is equals to temp.next, and the things are done. Things are pretty much done. Here we can simply write the driver code where I will define the object of the linked list class. So I can say list, which is linked list. Here I can define linked list class, right? Now I can call the function list dot insert at beginning, and here what I can define any of the numbers. I hope that the function calling will be correct, right? So this is the function calling which we are doing here, and here we can define, for example, 12. After that we can do few more function calling here. For example, here it is 8, here it is 9, here it is maybe 10. So 12 came, after that 8 came, so 8 should come front of 12. 9 should come front of 8. 10 should come front of 10. So our output should seems like 10, 9, 8 and 12. So now if I will try to just do the printing of this list, list dot, what I can do, print list. So if I will just run this, let's try to run this, we'll see. Correct? So here if you will observe, we will be able to get the outcome. So 12 came as the initial. Then after that 8 came, so 8 will come at the front of 12. That is the meaning of insertion at the beginning. So here 8 came at the beginning. Then after that 9 came. So 9 should come at the front of 8. So if you will observe here, 9 is coming at the front of 8. When we have 10, 10 should come at the front of 9. So 10 should come at the front of 9. This is how our complete full-fledged linked list should look like, right? 10, 9, 8 and 12. Now this is what we have understood, the insertion at the front, or you can say at the beginning of the linked list. Now insertion can also happen after any particular node, meaning what I want to convey here is that okay, we have understood that how insertion will happen at the front, but I can also pass now that I want to insert maybe here at this position after 40, right? So how insertion will happen after any of the node is the second use case which we want to discuss, and which I will discuss in my next upcoming video. And afterwards I will also discuss in the next video how basically the insertion will happen at the very end. So for insertion as well as deletion, we will always encounter with three cases. Insertion at the front that we have discussed just right now, insertion after any of the node, and then insertion at the very end of the node, very end of the linked list. So these are the three instances which we need to discuss. But now because we have discussed the insertion at the front, it's my humble request to everyone, just try at least once what should be the pointer change will happen. If suppose I want to insert the node maybe here. So let me remove this. Let's not discuss as of now this part. Suppose I have the data, for example, 52, and here it is none because it's a new node, and the address is suppose 300. I want to do the insertion between the 40 and 69. So what I want as an output now, 10 is there, 20 is there, 40 is there, and after 40 I want the data as 52, something like that. So how basically I will do the insertion? What are the nodes, I would say pointer shifting will be required in order to do this task, right? I would like to listen from you all. And if suppose you will be able to get the idea that how we can do the implementation as well. What you can do is that you can use the same function which I have discussed here, create insert after any node, and do the same thing, try to use the same approach, and we'll see whether you will be able to get the correct response or not. So far, we have seen that what is the major objective or the intuition behind the linked list data structure. Afterwards, we have also discussed that how this linked list is different from the array-based data structure. After that, we have seen how we can do the insertion in a linked list at the very starting of the node or after any of the node, right? Now in today's part, we'll try to discuss how we can do the insertion at the end of the linked list. Meaning of that is, so this is the third case of insertion which I want to discuss. Insertion at the end of the linked list. So let's get started. What I will do is that I'll try to first of all create a linked list here, just like the way I used to do, so that I will be able to explain to you the points pretty well. So here suppose I will be having the first node. Here suppose I will be having the second node, the third node, the fourth node, like that. Perfect. Here suppose the data which I am storing here is 2, 4, 8 and 12, right? And consider that I just usually take a random address only. I don't have any love with this addresses, but I found it quite easy to understand and easy to write. 100, 200, 300 and 400. Okay. Now, obviously, because this is our first node, so this is something which we can store inside the head pointer, right? So 100 will store here. Now, this will point to the first node of the linked list. Now, what will happen? This 200, this is 300, perfect, this is 400, and here it is something which we have is none. Perfect. Now, if I want to store any new node, for example, I will first of all create that new node. I will be having the new node whose data value is 20 and the next pointer is none. So this is something that we can consider it as the new underscore node. Obviously, it will also have some different address. For example, 600 is the address of this node. Now, I want to store this particular node after this 12, means at the very end. So wherever the ending node is there, I want to store it there. So basically, what I want is that in a nutshell, I want that this pointer will be changed from none to maybe 600 so that it will start pointing to this particular node. Can I say? This is what our objective is all about, so that it will start pointing to this particular node 600. Perfect. Meaning that what we want here is that we need to first of all traverse the complete linked list until the last node which is present in the original linked list, and after that I can make a shift to the pointers. Perfect. So in this way we will be able to get an idea that what should be the approach that we should follow to find out this particular solution. So what can I do here is that I can obviously create one function, but what are the steps inside that? What I can do is that I can maybe take some temporary variable or temporary pointer whose value I will start with a self.head. So this temp will initially store the value as, can I say 100? Right? Now we will try to make one while loop here, which will traverse until the value of the temp.next is not null. Until the value of temp.next not null. Why I am saying temp.next and not temp? Because I want to stop here at the last node. So what will happen is that until or unless I am saying that the value of temp.next is not null, do one thing, just keep on traversing the node towards next, 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 and so on. That is what we are doing. So let's get started. Temp is equals to 100, right? Now it will check what is the value present at temp.next. So we all know in a node we have two things. One is the data, which is this, and one is the, I would say, pointer. That is this. Can I say? Now when I'm saying temp is equals to self.head, so what I'm saying is that the value of the temp is equals to 100, correct? Now it will start from this. It will just check what is the value of temp.next. What is the value of next? 100's next. So this pointer name is something which we are setting as next. It is 200, which is not none. So what I will do is that I will update the value of temp with the value of temp.next. So temp.next is 200. One thing I hope everyone knows, but still let me know whether you are clear with this part or not. When I'm saying temp, value is 100 because I have initialized with the value of self.head. So when I'm saying temp.next, when I'm saying the value of temp.next, if I'm asking to you, you need to see that for that particular node, what is the next pointer which I am getting? Here it is 200. Can I say? What is the value of, if I will ask from you, temp.next.next? What is the meaning of that? What is the value of temp.next? First of all, you need to find out this thing. Because I found that a few students usually got confused in these pointer things. So you should be pretty much good in that. Then only you will be able to solve any of the linked list based question. Otherwise, for sure you will face some trouble or some ambiguity will be there in your head. So please try to understand. So what is the value of temp.next here? If you will see, the value of temp.next is 200. So I will reach here, right? What is the value of 200.next? What is the value of next in this 200 pointer? It is 300. So 300 will be the final answer. So this is how basically we usually see. So now when I am saying temp is equals to temp.next in the code, because the value of temp.next is not null, so I will just update the value of temp to 200. So now my temp will start pointing to this particular node. Now again, before going inside the while loop, it will just check the condition. What is the value of temp.next? Means 200's next is 300. Again, it is not null, right? If it is not null, again I will go inside this while loop and I will update the value of temp as temp.next. So here the value of 200 will get updated to 300. Can I say? So here the temp pointer will now start pointing to 300. Now again it will check before going inside the while loop, what is the value of temp.next? It is 400. Because it is 400, so it will go inside the while loop and will start pointing to the node 400. Will start pointing to the node 400. Now what is the value of temp.next here? Now if I will ask you, in the original list, I think everyone can see with the white marker, white pen, the value was none. Because it is none, so it is for sure that it will not go inside this while loop, right? The value of temp.next will not get updated now because it is none. So once it will go outside the while loop, what I want to do here is that I will just try to update the value of whatsoever be the new node address I have with the value of temp.next. Can I say? Can I say? So here, what is the value of new node? It is 600. So I want to just update this value of 600 to temp.next, which is 600. And this is how the structure of complete linked list will form like. And that is how basically I can do the insertion inside the linked list. So one tip which I want to give to everyone, whosoever is facing any question in an interview related to linked list, just try to go the way I am explaining to you. Meaning that whenever you are finding any question with respect to the linked list, first of all, try to manually create the linked list, manually just assign the addresses of every linked list and see the linking. Once you will be able to find out that at which pointer you need to find the linking process, then it's very easy for you to determine that how basically you can reach to the solution. So simple thing that you need to do for any of the linked list problem is that, first of all, manually create the linked list. Secondly, see what's the objective, what's the result you want to get. And then thirdly, see that which are the pointers. If you will do the shuffling or the interchanging of those pointers, will you be able to get the result or not? And how? So once you will be able to get that with what pointers changing, I will be able to find out the outcome. After that, it's very easy. Why? Because then you will be able to get the logic that how we'll be able to reach that particular node. Because always remember, whenever we are talking about a linked list based data structure, we already have a discussion in a very lot of depth that there is no random access which is there, just like in an array based data structure. So if you will be able to get that, okay, at this particular node I want to reach, there is only one way. That is, you need to do the traversal. For doing the traversal, you have just one option, that is to initialize the pointer with the self.head value. Take one pointer, initialize with that, and then start traversing, right? So there is no random access possible. So there is one option that we have here is the traversal thing only. Correct, everyone? So this is how with these steps, I think we will be able to do the insertion at the end. We will be able to do the insertion at the end of the linked list. I think this is quite obvious now. Now let me do one thing here. Let me try to open the Jupyter notebook. What we can do here is that I can just copy the previous code that we did of the linked list so that we don't need to create the classes again and again. And inside that, what I can do is that I can simply write the function of insertion at the ending part. Before that, I need to see where is the coding file. I think this will also work. So let me just open this. What I can do here is that let me just copy this code, which we have just discussed in our, I think, last to last class. Now, what I can do here is that I think I have downloaded this. I need to open the new file here. Okay. Now, what I can do is that I can just open the new terminal. And here, let me copy the code that we have discussed. Okay. Now, it is very easy for us because we just need to change the method by saying insert at end. Let me write this method name. So self and the new data will remain same. Here I created the new node, and here the logic will be changed because here we want to do the insertion at the very end. So what we can do, we can initialize one pointer whose value will be initialized with self.head. And after that, what we can do is that while the value of temp.next is not none, what we want to do, temp is something which is equals to temp.next. After that, once we will be out of the while loop, the very last step which we want to do is, majorly, what we want is that the value of the temp.next, we need to update that value with the, what I can say, new node. Correct? This is what we have discussed. Let me go back to the documentation. I think that is the only step we have discussed, right? Initialization, after that while loop traversal until we reach to the very end of the node, and after that the final step where I am just assigning the address of the new node to the temp next value. So that is what we did here, correct? So I think it should work fine. Now let's try to maybe see that whether it is working fine or not. So what I can do here is that instead of calling the function insert at beginning, I will call the function insert at end. So now I just copy this function name and will paste it everywhere. Done. I think all those things will remain same. If we will try to run this code, insert at end. Next pointer is there. So while temp is equals to self.head, while temp.next, temp is equals to temp.next. I think this is pretty much fine. Function name is also fine. here there is one issue. What is that issue? We missed one situation where if suppose the list is empty, that's where we are finding the trouble. Because here, if you will see now, one thing which is happening, that when we are passing insertion at end at the very first phase 12, there is actually no node that we have. There is no self.head. So how it will start assigning that pointer value to the new pointer temp? So I think we need to handle that case, and after that the problem will get resolved. So what we can do is that we can just pass one condition. So here what I am saying is that this is the condition which will be working when the linked list is empty. In that scenario, what we are saying is that if suppose the self.head is none, that only is the thing which indicates, I think, that the list is empty. At that point of time, what I want to do here is that I can assign directly the value of self.head as the new node address that we have, correct? And we can simply return out of that. I think this is the task that we can done, right? Because consider a scenario where what I can explain to you is that suppose here I don't have already created linked list that I have like 2, 4, 8, 12, and the list is empty, and you are passing so here in our code we are passing the very first node as 12 and none. Now in that particular case, this is if you are doing insertion at the end also, then also it is the very first node. So at that point of time, if the list is empty and you are doing a first insertion, you are doing a very first insertion inside the linked list. So at that point of time, what you need to do, you just need to place the value of, you just need to assign the value of self.head as the new node address that you have, right? And you can simply, I would say, return the list, right? I think this is making sense to everyone, and I think now our code should run. Let's try to see if it is giving us the error again or not. I think we are good to go, because now that 12 which it was giving me the error, that issue was resolved, because now we will be able to handle the situation, right? We are handling the situation where the linked list is empty. Initially we are not handling that kind of situation. So I hope that everyone is able to get an idea that how in a linked list we can do insertion at the very end. Apart from that, coming to a generalization part, given any kind of a question with respect to a linked list, how should we approach for that? And always remember that you should handle the base case conditions also, otherwise it might cause the trouble to you. Just like the way we forgot here, don't do this mistake again, right? So with this, I would like to end this particular session. I hope that you really enjoyed this session a lot, and with this, happy learning to all. Bye bye everyone, and I'll see you all in my next upcoming video.